Hey y'all, just give me a couple minutes to set up and then we will get started. Okay, so here's what I want to do today. First of all, an important announcement. I'm moving the midterm back 1 week. And the reason I'm moving it back 1 week was that when I set the original schedule, I forgot that the university had pushed the start of the semester back by 1 week. And I kept the midterm at its normal time, which turned out to be a week too early. I want the midterm to basically fall in the middle of graphical user interfaces so that you've had a brief introduction to graphical user interfaces and you've seen the solutions to the exception handling homework. So I'm moving it back by 1 week to March 9th. It's going to be an online exam. You're not going to have to come into the university to take it. I have not yet decided how to conduct it. It will be a Canvas exam. That much I do know. I'm not sure if I'm going to use the Respondus lockdown browser yet or not. So I'm still trying to work those issues out. So stay tuned for that. Before we get started, there's a couple homework issues I want to talk about, especially a bunch of you have been getting some compilation issues with packages, and I think I know what the issue may be, even though I haven't seen anyone's code, so I want to address that. I want to show you a trick with constants that I could have used in homework 3 and didn't. And then the main subject today is going to be JavaGenerics, how to write templates in both template classes and template functions in Java. So let me get to the homework issues. And many of you have been saying that something can't compile. And I think the issue, one of the issues might be if you have a package like rectangle.java and you're saying import java.graph, I'm sorry, if you're saying import graphics.star to try to get access to the remaining ones, and then you try to compile in that directory, you get a bunch of error messages saying that rectangle extends graphical object, class graphical object cannot find that symbol. So rectangle.java cannot find symbol, extends graphical object. And you're like, what the heck? I mean, graphical object is here in the same directory as rectangle.java. I have my import statement. What could go wrong? Okay, well, first of all, you don't need the import statement. Okay, it will naturally look in this directory for other things. So notice if I take the import statement out, whoops, did not work. Took it out, package. Well, good. So before it was compiling, let me just try something. Works there. So I can compile everything in the directory. So let's just remove the class and just try to compile rectangle.java. Okay, so I get a bunch of errors, even without the import statement. Okay, so what's going on? What's going on is that if it's going to find other things in the graphics package, then it's going to be looking for a directory named graphics in the current directory. Well, there is no directory named graphics. If you look here, you see all my class files, but the directory graphics is actually in the parent directory. Okay, so that's where graphics is. But when I try to compile rectangle.java, when I try to compile from within the graphics directory, it can't find graphical object because it is trying to find a graphics directory that is a subdirectory. Okay, what's important is graphics is not a subdirectory of graphics. It's a subdirectory of solutions, which is the parent in this case. So if instead I say Java C source path dot, which will look in the current directory, dot dot, which will look in the parent directory, it's happy. And the reason it's happy is because when it goes to the parent directory, it finds a directory called graphics, and that graphics directory has a .java file called graphicalobject.java, and so everything works. So I think what's causing a lot of your compilation difficulties is you are failing to use the source path and class path flags to indicate where the graphics directory can be found. You're assuming that you can compile from within the graphics directory, which is false, because when Java looks for other files, it's going to look for the graphics directory to be within the current directory, and it's just not there. Is that clear? Because this is causing problems for a bunch of you. No questions? Okay. And you may end up having to use the class path variable when you run graphics driver as well, because it's not going to be in this directory. Now, many of you will get lucky because graphics driver will be in the parent directory, but I would not be so lucky because my graphics driver is here. So if I compile graphics driver here, it fails because it can't find graphical object. So I have to use source path, tell it that in this case, the graphics library is in the solutions directory. And now I believe I can compile graphicsdriver.java. And again, when I run it, if I just try to run graphics driver, it doesn't find it. Let's see. Could not find or load. Check something. Whoops, it shouldn't be in. Let me redo the compilation. Okay, so it's outside the package. And I want it to be able to find, did I do an import? I did not import, so I have to import graphics dot star. Now it compiles just fine, given that I gave it the solutions package. If I try to run it, interesting, it runs fine even without the input file. Just a second. Make sure I have the input file. Yep. And is it doing anything? It's not doing anything here, so I don't. Interesting. It's not actually giving me an error message, but I don't think it's also able to find the right class directory. So what I'm going to do now is say Java class path dot solutions, because that's where the graphics package is located. It's still not working. Okay. I need to fix that. I will take a look at what's causing that trouble, but it would appear, I'm not sure what's causing that issue. At any rate, because graphics is not in this directory, if you look at my directory here, you don't see graphics. When I invoke the virtual machine, I'm almost certainly going to have to use the class path variable in order to let it know where the classes are that are associated with the graphics package. And I'm going to look at why it's not working right now with my input and get that fixed. But you got to be careful. Once you get into packages, you're going to have to start often using the source path and the class path variables to tell the compiler and the virtual machine where the directories are that contain your package directories. Here's the other thing you got to be careful not to do. When you specify the directories to look at, do not actually include the package name. So this would be wrong, because now you're telling Java's virtual machine to try to find the graphics package in a directory called solutions graphics, and graphics doesn't exist in the solution graphics directory. It exists in the solutions directory. So another common mistake is when you specify the source path or class path is appending the package name to the end of the directory. You don't do that. You leave the package name off because it's looking for the package in that directory. So in this case, it's going to look for a graphics directory in solutions. Therefore, you do not include graphics as part of the path name. So that's the other common error that I've been seeing. Okay. Questions about that? Okay. Now, in homework 3, I made you use an enumerated class for arc constants. And it looks something like this. Let me go to my ignore implements arc size for a moment. So you had an enum arc constants or arc size or something. It was arc size, I believe, in the homework 3. So you needed 3 constants, small, medium, and large. They each took a size in pixels. So you declared a protected variable for them, and then the constructor simply stored the size or the value you passed in the constructor to size, and then you had one public function called getSize that returned size. Now, the issue I ran into in my program is that I really wanted arc size to be an integer. And so when I designed the program, I designed it so that it was using integers. And when you created your solution, what I wanted was for the arc size to be an int. But in the real world, the ideal thing is that this variable for arc size should be able to store either a constant or an int. You'd like it to be able to store one or the other, and not to force the conversion of the constant to an int, which is what I was doing. And the way you can do that is to have the arc size is to define an interface. So I defined an interface called arc size and had it return an int from its one public method called getSize. So I could always get an integer from a variable of type arc size by calling getSize. Then I had my enumerated constants implement arc size. So they implement this method. So now an arc constant can be stored into any variable that is declared as an arc size. Okay, so I wrote a main program called tester. And in tester, I had a variable called arc size. And you can see that I assign it arc constants dot small, and I print out a, and it will print out that arc size of a is small. But I also want to be able to store an integer into arc size. I don't want to limit myself to those three constants. So the way I handle that is I define a second class called arc value. And arc value can hold any arc size I want. So there was a second class called arc value that also implements arc size, the interface, and implements this public method, getSize. And because it's not a constant, you're allowed to both set its value and you can get its value. And I declared a toString method so that it could be printed out that returns the string value of its size. So now in tester, I can also store a arbitrary size arc size into A. So A equals new arc value. And because I associated a toString method with it that does something nice, I can also print it out nicely. So using an interface, it allows me to actually declare a variable of arc size rather than of type int, because I really am talking, I know arc size is an int, but what I really want to be able to do is store either a constant, one of the predefined constants, or I want to be able to store an integer of an arbitrary amount. And the way I did that was by defining a common interface for arc constants and arc value. And that way I could store either one into the variable A. So this is an important use of interfaces in Java. They allow you an interface. So an interface can allow you to store values of different types. Just a sec, no, I'll get to you. Can store values of different types into the same variable. as long as they support the same interface. Noah, was it you who had the question?
I did raise my hand, but I think Manny had his hand up first if he wants to ask first.
Okay, go ahead, Manny.
Sorry, I had my hand up from earlier when you asked if we could hear me. My bad.
You
Oh,
can
okay.
just, it's probably easier to break in. It's not as I only briefly see the hand going up and then it disappears for me. So don't be afraid to speak up. I'm always okay with an interruption.
Okay, yeah, I would have, but you caught in time. Anyways, I got a question about this right here. So I understand that you're doing this to demonstrate how interfaces can be used to support multiple types, but is this what you were expecting for this specific case? Because
No,
draw round
absolutely not.
rectangle.
Absolutely
Okay.
not. I figured
Okay.
this out after the homework assignment was due. I was actually thinking it's pretty crazy that Java gives you these constants, but then it doesn't allow you to mix those constants with other types of values. And so then I went out and figured out how to do it. So the answer is no, I absolutely did not expect you to do it this way for the homework assignment.
Okay, thank you.
So don't
follow-up question.
But I may, in the future, you all won't be taking this course again, hopefully, but in the future, I may modify the homework assignment because that is actually probably the better way to do it.
I gotcha. But I do have a question, more of a, I guess, a pragmatic sense. So for this, that variable is then going to be used with the draw around rectangle or fill. I don't remember which one, which expects an int as its arc height and arc width. So would it be better to force it to be an integer here, or
Practically
again, was this
speaking, I
just...
think so. Because as long as you have some integer constants like small, medium, and large that predefine that the user can use, I think from a practical standpoint, it would be better to just define or declare integer constants rather than go through this kind of complicated constant mechanism that Java provides. So I was more doing it for pedagogical reasons to force you to get some practice with constants. But yeah, from a practical standpoint, I think a lot of people in the Java programming language community think that while the Java constant mechanism is a pretty powerful mechanism, it's also overkill. And that the old C++ way of just defining integer constants is often easier.
Okay, I understand that. Thank you.
So I will generally, if I want you to use a constant from now on, I'll probably just say you have to use an enumerated constant just so you can get some practice with it. But you may well find in the real world that you never use them. Other questions?
At least we know they exist, right?
Yes. Because some places will use them. They do come up actually in graphical user interfaces a fair amount because you do want them actually for things like fonts and colors and some other stuff.
Which makes sense because that's really what Java does. I mean,
like for example, with a color is actually defined with an RGB value, red, green, blue, and there it becomes more of a option to use a constant because now otherwise you're looking at what? You have to store a class or something anyhow. It's no longer really a primitive type. So those constants may also be more valuable when it's they're embodying something that is more than just a single primitive type, like a color, which is a composite of 3 different values. But I digress. Let's move on.
That makes sense. Thank you for elaborating. I mean, I think that gives context to it for sure.
Oh, thank you. That was kind of also just off the top of the head, but it did help me realize why I find them useful. So thanks too. Okay, Noah. Question? Or was that Noah?
That was
you,
Noah just now. So all is taken care of. We've cleared the board.
Okay. Very good. Okay. That case, let's move on to JavaGenerics. So today is the second day on generics, and you're going to find that JavaGenerics are much cleaner than our C++ generics. So I showed you how to create a box template in C++ the other day. In fact, let me bring it up again. Whoops, that's Java. I didn't mean for that. Okay, so here was what the C++ template for a box class looked like. So it was just storing a value, and you had to prefix it with this template header. It's like a function header. So it's like saying template, and these are my, it's like instead of function keyword, it's a template keyword, and then your template parameters, and then you had your class. And then you had to go through this rigmarole with including box.cpp. And then in box.cpp, you again had to prefix every method with this template header. And then you had to also remember when you prefixed the method name with the class name to include a list of the type parameters. So it was pretty kludgy. So as a comparison, let's take a look at the box code in Java. And this is the complete code in Java. So there's no template declaration. All you have to do is, if it's going to be a template class, after the method or after the class name, you simply give in diamonds a list of the template parameters. And they have to be unique names. So you might say T1, T2 if there were two different types. Or there's some conventional values. If it is a key, it would be K. If it's a value, it would be B. So if you were defining a map, for example, the convention would be that for a class map, the convention would be that you would say K, comma V to indicate that your two type parameters are a key and a value. But if it's just a generic type, you would tend to use T1, T2, T3, etc. Here we just have one type, so we just use a capital T. So the value is going to be protected. I probably could have used a better variable here than T. Value would have been a better name for the variable. And my add method allows me to add a new value. So because I use the same name for the parameter as I named for the variable, I had to disambiguate them using this dot T. So this dot T refers to this protected variable. This T refers to this local variable, which is more tightly bound. So if I just refer to T here, what I get is the most recent declaration of T, which is this T from the parameter list. If I want to get to the T instance variable, I now have to disambiguate it using the this. And finally, my get method returns T, and the return value is T. So none of this template header stuff that you saw in C++, plus the method bodies go inside the class, which makes your life a lot simpler in Java. So in Java, when most of your template classes are this simple. You simply add for the class declaration this diamond box and then the set of type parameters, and then inside the class declaration where you would normally have a specific type, you replace those specific types with one of your type parameters. So pretty simple. There is, so any questions about that? Because in 5 minutes, I've shown you the basics of declaring templates in Java. Everything we do now is going to be an elaboration of this. It's going to be adding some bells and whistles and showing you some limitations. This is, though, it in its most basic form. Okay. Now, as I said, there is a limitation in Java, which is that the type has to be a class. It can't be a primitive type. And the reason that is the case is that Java compiles only one piece of code. So in C++, this code could not be compiled. Instead, it had to be instantiated with a specific type. And then when you instantiated it with a specific type, it would replace the type variable with that specific type and compile the code. So it would do type substitution. And if you instantiated it with 3 different types, like int, string, and employee, it would create 3 different instances of the code. This is C++, and compile 3 different versions. Java doesn't do that. What Java does is, in this case, it replaces T with object, which is the top of the class hierarchy in Java. And so what it does is something called type erasure. And what it actually compiles is this piece of code. So wherever there was a T, it replaces it with object, which is the top of the Java class hierarchy. So it's actually able to compile the code. And then what you don't see is it is putting downcasts into your code when you access the box. So for example, if you have in your code box, say string, name equals new box. You'll see I don't have to, in a moment, you'll see I don't have to do this. And then I think it was name.add. Brad. And now let's say I have a string value equals name dot get. Okay, if we go back and look at the code, you see get is returning a type. But right now the problem is Java compiled it so that it's returning an object, which isn't what we want. We want a string. And so what you don't see is that the Java compiler adds a downcast. It adds a string downcast here. So in fact, what gets compiled by the Java compiler is a statement that has a string downcast in front of name.get. So you don't see any of this going on behind the scenes because the Java compiler is doing it all for you. But that is what is happening, is that Java is in effect erasing that type T and replacing it with object, and then it's compiling the code. So unlike C++, in Java, the template code is compiled, and it's compiled into a .class file. And then Java is downcasting anything that returns a value into the appropriate type, because anything can be cast to an object. Any object can be cast to an object. So any place where you are passing in a parameter, no cast is required because Java is always willing to assign something, a value to a variable of type object. It's only on the return where it's returning something of type object that it becomes a problem, and now it does a downcast. Okay, and again, this is called type erasure. When you hear the word type erasure, that is what is going on. Java is replacing the type T that you see here with the value object. Okay, so pretty straightforward. And when you create something, now when I declare something of type box, I can create it and explicitly provide the type parameter. But starting with Java 1.7, you can omit the type, not the diamond. You can't omit the diamond, but you can omit the type in the new constructor because it can infer that it's creating a box with a string from this declaration on the left. But you notice I bold-faced, you still have to use the diamond operator. If you don't, it thinks that you're trying to create a box that will hold an object, and that's no good. So you just got to be careful about that. If I go to my box tester program, whoops, not that one. Do I have a box? May not have it. Okay, I'm going to have to copy it. So let's do class test. Create this class. So we'll compile and run it. And what is my issue? Constructor. Let's just look at what I have in Java. Okay, so in my box class here, I had a constructor that actually took, it was a one argument constructor. So what it's complaining about is in test.java, I did not give it a value. So let's give it Brad as a value. compile it. So now it runs. I can say, give a command line argument, and it's actually storing. What is it doing? Java test nils. There we go. So it prints out nils. Now what I'm going to do is I'm going to get rid of string there, and it should still compile. And it should still run fine. But the last thing I'm going to do is I'm going to also get rid of the diamond operator. And now it complains, uses an unchecked or unsafe operation, recompile with xlint unchecked for details. So now I can recompile with that to see what the problem is. And you can see that it's giving you T extends object, B equals box. It's just not really giving you maybe as much as you want until you get down here where you see it says required box string, and instead what it found was box. So bottom line, just be careful that you don't omit this diamond operator right there, or else you'll have some issues. Okay. Now, you can also declare generic methods in Java. You'll notice that here I had a generic method, and as long as you're using a type that was defined in the classes type parameter list, you don't have to go through any extra pageantry. But if you are, just like I saw a question, someone raised their hand. Question?
Yeah, I was going to ask, could you show us what happens if you run it through the error?
Through the error? What do you mean?
So I believe you had to turn on the tag to stop the error, but can you show us what happens if you would actually just run it with?
Oh no,
without
what
that
I did was when I ran it with this tag, it compiled and gave me more information about the error. It did not actually compile it. Wait, maybe it did. Let me check. Remove test.class. Exception. Oh, that's because test foo. Looks like it still worked, even though I removed the class. That's interesting. So the answer is it still worked, which is pretty surprising. I'm going to take off this because that was just giving me more information. Yep, uses unchecked or unsafe operations. So it's still compiling and it's still running. I hadn't realized that it actually still compiled it. It's just, I'm not sure what's going on in this case, I'll be honest. But I know that it's not safe. So you definitely want to make sure you use the diamond operator. Okay.
Okay, thank you.
So I know that's not a very satisfactory answer, but I hadn't realized that I had thought it was actually throwing an error, and you correctly caught the fact that it was a warning, and that it's actually still recompiling. That so it let's see. Okay, apropos of your question, here's another class where I was illustrating the issue. I'll check that later. I'll just move on for the time being. Okay, so with generic methods, as long as you use one of the types declared in the class's type parameter list, you don't have to do anything extra. But here I am declaring a method and it's using a type that is not declared in the class's type parameter list. So it's declaring an additional type parameter called v. And in that case, I have to prefix the method declaration with the additional type parameter or parameters. So here, there's an additional type parameter v. So it's taking an array of data of type v and printing it. So this is how you get implementations like for sort in the collections library, where it's the class that is being declared is effectively just a class of methods. And so there is no real type parameter for the class because the class is just serving as a wrapper for a set of methods that you want to declare, like sort or min or max. And in that case, you have to, in front of the method, in front of the return type, you have to declare the type parameters that you're using in that particular method. Okay, we're not going to worry about declaring these types of methods in this class. So for example, in the homework assignments, you won't have to deal with this type of generic method, but you need to know that it exists. And then when you invoke that generic method, you can ensure that it knows what the type is by giving the type in front of the method, but oftentimes it can infer it from just the type of the argument. So in this case, if args is declared to be a string array, the Java compiler can infer that v's type right here is string. But if you want to be safe, you would always explicitly pass in the type parameter or type argument. If you want to be succinct, you'll see if the Java compiler can infer the type, which it usually can. Okay, so this is all well and good, but let's say that you want to ensure that the, okay, let me write it out. Let's say that I want to define a method. In this case, I want to define a map, a sorted map, tree. Let's go with a tree. I want to define a tree template class. Well, in order to define a tree template class, we really need the keys to support a compare operation. Okay, so that means we need the keys or the key type to support a comparison operation. We need to be able to compare two keys. The problem is that object does not provide a compare operation. It provides an equal operation, but not a compare. So if we try to define a tree, a class tree, as say a K and a V, the problem is when K gets replaced by object, then our compare operation will fail because object doesn't have a compare operation. So the question is, how can we specify that K needs to be able to support a comparison operator? The way we can do that is by having it extend an interface. So what I can say here is that K extends, in this case, comparator. Yes, comparator. You may remember that comparator takes, actually it's not comparator, I think it's compare to. Compare, let me check. It's not comparator. Comparable? Comparable. I believe, yes, it's comparable. So I don't want to extend comparator. What I want it to do is extend comparable. And if you look back at what is the comparable interface, the comparable interface has this one method compare to. So what we're saying now is that in order to be a key type for a tree, that type must extend the comparable interface. So that will give us the ability to compare two key objects. Okay, and what this comparable is called is called an upper bound. And when Java does its type erasure, it will replace K with the upper bound, which in this case is comparable. So in fact, what type erasure does, I told a white lie before, type erasure actually replaces a type parameter with its upper bound. And you are allowed to extend either a class or a interface. So for example, let's say I want to have something that is able to do operations on numbers. So for example, I want to be able to have a class compare number. Then I could have it be, say, n extends number. And now I can, number is a class, I can have anything that extends number like integer, short, float, double, any of those could be used to instantiate the number class, and I would be allowed to use anything that is in ends interface. So you are limited to using, using the operations declared in the upper bounds interface. Meaning it's public methods. So actually, you may be extending the number of operations that you can use when you use an upper bound other than object, because object has a very limited number of methods. It has a hash code method, a compare or an equals method, a toString method, but it has a very limited set of methods. So oftentimes when you declare a different upper bound like number, you're actually expanding the number of operations that you're allowed to use. Okay, so that is the upper bound. Okay, now there's another problem. So this is called a bounded type parameter. Another issue we run into is, here's an example where we are declaring a list of numbers and we're assigning it a new list of integers. It turns out this will not compile, which is a little bit puzzling because an integer is a subclass of number. But the problem is that my list, this is saying that my list can store any type of number, including floats and doubles. So the Java compiler is saying, whoa, 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 wait a minute. This declaration right here says my list is allowed to store floats and doubles, but you just assigned it a list that is incapable of storing floats and doubles. So I'm going to complain. So you can get around this restriction using what are called upper bounded wildcards. So in this case, you would instead say that I can store anything in this list that extends number. And now, so here I'm writing a method that is able to sum the elements in a list, and I want it to be able to sum any type of list, whether it's integers or shorts or floats. And so I'm saying that it can store anything that extends a number. And now the Java compiler is happy. It will allow us to instantiate this list with anything like integer or short. And here you can see it is able to add those numbers and return them. And because a number is able to, one of the methods supported by number is the ability to convert a number to a double value. You're able to sum them up, assign them to a double, and return S. Okay. And then here is an unbounded wildcard. So in this case, this list is allowed to store anything. You can't do a whole lot with this list anymore because it means the only methods you're allowed to access are the methods associated with an object. But one of the methods declared by an object is the toString method. So you can print that list by printing out elem, because that will call the toString method, and that is one of the very few methods that an object does support. Okay, so there's a difference between a bounded type parameter, which is by itself, and one that uses a wildcard because it's inside of a container, like a list. So there we're talking about, when you hear the use of the word wildcard, it means that it is a type parameter that is inside a container object like a list, a set, a map, etc. And you can also do lower bounded wildcards. I will admit, I have never seen them used in practice. So if I want to say that I am storing a list of integers, but I'm also allowed to store anything that is a superclass of integer, like say number, then I can say list question mark super. Notice before it was extends for the upper bound. For a lower bound, I can say super, and now any superclass of integer can be stored here as well. Okay, but that's kind of, since I've never tried to play with this in practice, I'm not really sure what this buys you. As I said here, this allows you to also store a list of objects because object is a super type of integer. So you can't perform any, you can't use any of the methods defined in the integer interface because object doesn't support them. So effectively, when you use this lower bounded wildcard, you're saying, I'm going to limit myself to whatever methods are in the object superclass, because ultimately the top of the object hierarchy is objects. So to me, saying that I can store any super type of an integer in my list defeats the whole purpose of it, because I can't use any of the methods associated with integer. So as I've said, I've never seen this come up in practice. And I even thought a little bit about trying to give you a good real world example, and I couldn't come up with one. So I'm not going to test you on this. It's not in the homework assignment because I just don't really see the value of lower bounded wildcards. But I'm throwing them out there in case you ever see them. Okay, so the last thing we need to talk about is type erasure. Means that you get some restrictions on generics that you might not anticipate. So the obvious restriction with type erasure is that you can't use primitive types because as I said, the type gets replaced with the upper bound. The upper bound is object, but primitive types aren't classes, so you can't use them specifically in a generic. However, as we've already discussed, you can use their wrapper classes instead, and Java automatically does boxing for you so that you can provide the primitive type and Java will automatically box that into the appropriate wrapper type. That's the big restriction. But there are some more subtle restrictions too. One is that you cannot create an instance of a type parameter. So here, what I'm trying to do is append an item to a list, and I want to create a new element of that list and then add it. And I can't do it because this E in type erasure is going to get replaced with objects. So what is going to get created is not a new, like if I instantiate this with E with string, it looks like this should be creating a new string. But in fact, what happens with type erasure is that it gets replaced this gets replaced with a new object. So instead of adding a string, which is what you think you're adding to this list, you would really be adding an object to the list, and that's not what you want. So Java says, nope, you cannot create an instance of a type parameter inside of a generic class or a generic method. Okay, the next thing you cannot do is create arrays of parameterized types. So here I want to create an array of lists, and it's not going to let me get away with it. So I'd like to create an array of 2 lists that contain integers, and that doesn't work. And the reason is as follows. So here's an example. If I declare, let's say I have an array of objects, that's fine because I can store anything I want into an array of objects. So the Java compiler accepts this code right here, and it allows it to assign something like hi to string 0 because any object can be assigned to this array because it's a type object. You can't assign 100 because that is a primitive type. Now, let's try the same thing with generic lists. So now I'm assigning to object a list of strings, and later on I say string list 1 equal new array list of integer. And you think, well, the compiler should be able to catch that because I said that I was assigning a list of strings to object. But the problem is with type erasure, what's going on is that it thinks that we have, with type erasure, it ends up with this can be a list of objects. The compiler says, oh, an integer is a fine thing. Integer can be assigned to an object. So it says, that's great. And it compiles. But at runtime, this should be an error because you can't assign an integer to an array list of strings. But that can't be caught, it turns out. Java is not putting in any kind of runtime check because the compiler says, assigning an integer to an array of objects is just fine. No runtime check is required. So this would create a hole in Java's runtime protections. There's no way for Java's interpreter to figure out that you are assigning an integer to a list of strings. And so the Java standard says we're punting and you can't do it. You're not allowed to create arrays of generic objects. Okay, or at least lists. No, parameterized types at all. Okay, so there is a workaround. You could simply create a list of objects, and then that is fine. So this is not any parameterized type, so you're just storing lists of objects. Another workaround is you could use an array list rather than an array. So here I've defined my list of list classes, and I want my array list to contain an array list of strings. So I create a new array list of strings, and then I add to it 2 array lists of strings, and it works just fine. So I can add to my first array list, Brad. To my second array list, I add the items Yifan and Smiley. I then print out the items in the first list, and I print out the items in the second list. And if I compile this, so just to prove to you that I have a list of lists and I'm not doing anything funky, here is that code. I compile it. It compiles. And it runs. The contents of the first list is Brad. The contents of the second list is Yifan and Smiley. So while I cannot create an array of parameterized types, I am allowed to create an array list of parameterized types. So that is a way around the problem. Just you won't be able to use the nice array notation anymore. Okay. So that is the lecture on Java generics. I think that does it, yes. So what you need to know is you need to know how to write a class that contains parameterized types and the methods in that class. You need to know how to use upper bounds, both in, so you need to know how to use bounded type parameters, and you need to know how to use upper bounded wildcards so that you can get lists or containers of objects the way you expect. I will not expect you to be able to write code involving lower bounded wildcards or methods that require a type parameter that is not part of the class's type parameter list. Okay, I might on the quiz for today require it, but on the homework assignment, on the exam, I will not require that knowledge. So any questions about what I've gone over today with Java templates? Anyone? Okay. In that case, I am going to let you go. I am holding office hours in about 20 minutes. So if anyone has questions about the homework or the like, I will be available at 2:45 to take your questions. And I'm also available now if you want to ask any questions, but you're free to go.